Hello everyone, welcome to my, I think, 21st live stream. I hope you're enjoying the weekend so far, as I do. It's super sunny here again. Today I'm gonna play with Rust macros. I'll explain what that is in the beginning. My ultimate goal is to simplify the whole, let's say, creation of a query module and then adding the result types, adding implementation and all these things to be super simple and super straightforward. And Rust allows that in a very nice way because of these macros that can be really implemented in a nice way. So basically, that's the whole idea. I hope it's gonna be exciting and interesting. And this is basically the polishing phase of the whole Rust query modules project. Because yeah, now the primary goal is to simplify stuff. I'm also missing a couple of tests and stuff like that, but I'll add that later on. Yeah, as always, please like, share, and subscribe to stay in touch. For the future, I'll probably have one more live stream next Saturday, and that's gonna be it. But yeah, we'll see about that later on. And then what comes next, we'll see about that as well. I think I'm gonna switch to Rust client for Memgraph and deliver on that side. And then probably we'll add some more capabilities in the mage. But yeah, we'll see about that. Today the plan is to finish in, I don't know, hour, maybe 2 hours. Maybe I'll stay more because of the whole polishing that can be unpredictable and exciting if I figure out something that I didn't understand. And yeah, I also, yeah, keep in mind, and yeah, a disclaimer, I'm not an expert in Rust, so I'm trying to figure out stuff on the fly. So feel free to like suggest stuff and yeah, ask any questions if you have them. And that's it. So let's get started with the whole thing. Give me a second. Yeah, that's it. So, okay, here we are in the mage repository on the pull request. So I'll just quickly explain what happened in the past, but I'll ignore these results and tests for now. So this is interesting and this is interesting. So in the meantime, I've deleted all these manual stuff from the example module and basically put all of that into a nice macro that generates all this C stuff automatically. So the biggest difference is here. Now we have, so maybe before jumping in, I'll try to explain the macro. So in the, maybe some of you are familiar with macros from the C, where the, let's say, preprocessor just replace a keyword or a macro name with some code under the hood, and that's basically it. So it's in, for example, C, these macros are not really powerful, but in Rust, these macros are like evaluated and they are equivalent to the, almost equivalent to the regular code, even more powerful. They allow more stuff, and yeah, by utilizing these macros, it's very easy to like put in place nice constructs that can simplify the code at the end. So yeah, maybe just go here. For example, in the Rust, for example, print line is a macro that simplifies printing to the console, and there are a bunch of other macros in the language and also in throughout all the Rust libraries available. There are two types of macros, I would say, if I can say that. Macro, like the simple macro that is just regular Rust code, but there are also procedural macros. They are a bit more powerful because basically they allow you to like parse any text, anything, and then transform that into some kind of a code. But I won't deal with these procedural macros because I think we don't really need that. We don't have to create any like specific language for something or anything like that. I think regular Rust macros are enough for us. Okay, I hope I've managed to explain. Yeah, feel free to jump in and put any questions at any time. So I'll go back. So here we have define procedure macro. Basically, under the hood, that thing is generating a pub extend function with the right signature, and basically under the hood, it registers test procedure function as a Rust function that will be used in the module to run stuff, and then that test procedure gets the implementation of that let's say procedure or function. It follows here, and it gets the context. So once the macro is expanded, like prior to calling this function, context is created, and then it's passed to Memgraph. I mean to that function. And basically here is the implementation of the entire Rust query module. So this is the same as the last time. I'll refactor that a bit in the future, but basically we replaced all this code. So test procedure code, and then we have the implementation, and this part is here tricky. So before we had a test procedure C function with all the right signatures, and this function is required to be here because Memgraph knows how to call exactly this, like nothing else can be here. But yeah, from the query modules development perspective, a developer shouldn't write all these things. I mean, it can, but it's very time consuming and yeah, error prone. Plus, all these things here are important to be, let's say, put in macro, because this is even more error prone and it has a bunch of logic inside. So an idea is to catch if a query module panics, then we want to catch that and then return that as a regular error in Memgraph code, and also a bunch of other stuff. So it's not only about catching panics, it's also about catching errors, because here, so we call test procedure here, and then we want to catch that error and return that error to Memgraph as well. And this is all deleted code, but how that looks like in the actual macro code. So we have here define procedure. Macro rules is just another macro that generates these user macros. Here, macro export is just an attribute that tells that this macro is published in the crate, and each macro, basically that's what I've learned yesterday. So each macro is on top level of the crate. So we have RSMGP system crate. Maybe I can just increase this a bit. That's too big probably. Sorry. I hope this is big enough. Macro export will export that macro on the top level. of the crate, so RSMGP system crate, will contain that define procedure call. And how is that used? So whenever we'll write a query module in Rust, we'll have RSMGP system, and then on that top level there is close module, define procedure, and init module. So we are now explaining the define procedure, but we also have init module and close module macro. Okay, so let me just show you one last thing. So here we can specify each macro has, I hope these are called arguments. I'm not sure how is that called. Yeah, let's call that argument for now, because it looks like a function argument. So that define procedure macro has a C name. It's an identifier for that C function that will be created, let's say. And we have a Rust function. That's the lambda function that gets injected here. And now we are generating that boilerplate from C, and we are setting the hook. That's all from the past. And then this part here is interesting. So instead of having the exact, let's say, function name, we are calling RS function, so Rust function that will be passed as a lambda here. So here we have that expression that will be a function. And this is we can put here any lambda function. I mean, when we use a macro, we can put anything here. And CName here is important because here we have here we use that identifier, and basically that will be generated in the module code and then later on compiled, and Memgraph will have exactly that that name available and used. So okay, and then we also have here, so I will just skip all this thing here. That's all then the same. And in addition to define procedure, we have init module macro, which essentially the concept is the same. We just have here, we have to add a bunch of stuff about the error handling. I think the same as here. We have to put all these mechanisms in place as well. And then close module, again, the same principle. It's also, we just call a function that will close the module if we need to close anything. If we need to do any type of cleanup, that can be done here. Okay. And yeah, that's about it. Maybe just a note, how is that called? So close module, and yeah, Rust macro has this exclamation mark at the end. Basically it just says that that's a macro. And for closing stuff, we don't do anything at this point. We just pass an empty function here, returning null. For the define procedure, we actually have like test procedure here. That's the C name that will be used to generate the C function. And then we have this this function that is actually implementation of our procedure. And we also have init module. So init module is also a macro getting module and the memory object. And here we have to add that procedure, and we use here exactly the same test procedure. So this thing here and this thing here has to be the same. And yeah, basically when Rust compiler compiles this, it will generate this test procedure, like the entire body, replace that macro with a real code, and then this code here knows that this is expanded and that this exists. Basically, compiler doesn't compile about these things. Yeah, we have to say we have to specify the exact name, and then also the module. And that's basically it. So that's the first macro example in the code. And then what I also did was, so in the init module we had a bunch of these function calls, which are, I mean, I just put whatever I thought it's the best in the beginning, but it's also very repetitive and very boilerplate. It has a bunch of stuff here which are not really required. So I replaced all of that by specifying the exact, let's say, result field types. So we have here a vector. Again, this is a macro that will create a stud vector in Rust, and basically for each field that we need, we create another result object. I'll later on in this later on today, I'll try to replace this with nice macros. I think that's the best way. So this is how that should be done in the verbose mode, and then I'll replace that as macros. So here we have a name of the field, which is C-string. We have a field type, which can have simple type and complex type. This is what I've created. I'm not sure if that's the best possible solution, but basically the problem is that we have two types in the C API that are, let's say, composed. So we have list and nullable. So list can have a subtype. I mean, what is the type of items in the list? And also nullable, like a type can be nullable that can have anything under the hood. And yeah, maybe that's not even the best. Yeah, okay, I'll go get back to that later on. So, and then simple types are integer, bool, string, and stuff like that. And then we have complex type, which is list that contains any objects here. And how is that implemented? So if we go here, we have an enum in Rust, which has all simple types, all these things here, and complex type can be nullable and list. And then we have another struct that has simple type and optional complex type. So basically, if complex type is defined, then simple type will be also used. Otherwise, if this is none, then only simple type is going to be used. I'm now thinking, is it possible to create like nullable of list of integers, for example? And I think that's not possible with the current implementation. I have to change that. I have to do that in a better way somehow. And yeah, I think I'm gonna do that today. Yeah, the default stuff, and then we have the struct here, and then basically all this is not required anymore. I've moved all that code into add read procedure code. Basically, that's all now encapsulated here. So we call C add read procedure call, and then after that, we just iterating through all result fields. And basically, for each simple type, we call, we get the right MGP type. And then if complex type is defined, then we also have, then we also add that, like we create nullable or list of MGP type. Yeah. Yep. Yeah, I think this is not right because we cannot construct these complex types. I have to change that. But yeah, okay, we have, this is from before, and yeah, that's it. Okay, that's what happened in the past. I'll try now to fix first that composition problem, how to define these complex types, and then I'll try to replace this with some nice macro somehow. All right. Okay, we close this. We have here the documentation if we need that. We don't need this. We go back here. Let's go back into code. All right. I hope you can see this. Yep. So rs ngp. So here, how I'm gonna do that actually. So we need to make this composable somehow. And how to specify. So that's now an interface type of problem, because the question is how do we best compose. What did I do? Sorry. Okay. So yeah, we can have, I don't know, an array of types or something like that, but it's not really something we would like. Yeah. We can have, let's say, a type object type that can have another type or something. So result field type can have, maybe if we move nullable here and list here, we can have here let's say we don't need this. We can have a type, or maybe even so we need a type that has, like, we need a recursive type of things, and then once we have the recursion defined, then we can so let's say field type that has yeah, how to do that in Rust? How to actually do that? Yeah. I'm not actually sure. Maybe the best thing would be to have just an array of values and then just compose if that's possible. So yeah, an array of values that would be composed if possible. So I have list of integers, let's say, or nullable list of integers, and then we just have a vector of these things, and then we have rules in place that tell if that's fine, and then with macro we can just replace that we can just have variable expand in that area. Yeah. Let's refactor this a bit into a field type. And then we just result field type is a struct. And what about Rust enum? Can we put that in one enum somehow? No, because we have, like, we need these types and then we need additional value here. Yeah. Field type, result field type, which is field types. Let's say if we have a vector of field type. So now we have a vector of field type. We don't need this anymore. Field types. Types, and we have field type. Yeah. Okay. And then we have result field, which is a vector of that. Oops. Field type, result field type, it's unknown. Vector. We need a vector here. We need two vectors because one, like, procedure can have multiple arguments, and then, yeah. Okay, result fields. Okay. Sized, what is that? But we don't, but we don't want compile time. Do we know that compile time? We know, but it can be really anything. Result field A, yes. What if I compile this? Now I have a bunch of problems. Okay, let me just try to refactor this, and then we're gonna go back here. Result fields, field, yeah, field type. That's not gonna fly here anymore, so we don't need this. MQPType, yes. Field type, simple type. Types 0, not simple type. Instead of simple type, we need field type. Yeah, field type, but we don't have all of these things. Yeah, we have we'll just put here to do nothing on panic just for now to have this. All right, so okay, what if compile stuff now? Within the trait size is not implemented for field type required because it presents the type result field size and array elements must have size type. Dynamic sized array in Rust. What is that? Vector is a fixed heap array. But maybe we just cannot know this because we didn't actually yeah. Maybe if we compile this, so result field, okay, we have name, result field type, result field type, field type, result field type, types. So if we change this with, for example, types, result field type does not have this field. What if I say here, if I put here a reference, then we need to have a lifetime. Let's put a lifetime here. We need also a lifetime here. Yeah. By doing so, we are just taking a reference to that array. No simple type, no simple type. We have field type now. Yes. Okay. We have field type, but the problem is that we need a reference here. Yeah, this is going to work, but it's not that amazing. But yeah, I more prefer this because that will that's more correct. Bool string now we just put a string here in all places, not here. string, first label name, properties first, yeah, and then list. We need types, field types, this, field type list, field type any, list of any. Okay, that's good, but we'll have this here list, and that's gonna panic here because, yeah. Okay, and then we need to MQPType equals std ptr null mutable pointer, and then for field type in result field type dot types. Now we have a field type here, and we go, but we have to go backwards. Reverse Rust list reverse function, yes. Ref iter ref reserved. So no. Reverses the order of elements in the slice in place. So we're gonna reverse that. Okay, let's do that. This is a bit hackish, but okay, and we're gonna go with that. But the problem is also that types iter. This returns something else. This is not returning an array. Okay. Result of this. No. Yeah, we're gonna reverse that. What is cannot borrow as mutable? Yeah, we don't have a mutable thing here. So we have to copy that or do something with that. If we do this, we'll just get an error about the size again. Yeah. Do we have a copy? We should have copy. Or clone. Yep. Let result types equals result field dot field type dot types clone. So now we have these types. Okay. Reverse. This is again mutable. Cannot borrow types is behind reference. Cannot borrow. Why not? Cannot borrow types as mutable as it's behind a reference. I'm gonna just ignore this code for now. I again forgot about clone. Difference between copy and copy is not. Clone, yeah, we need clone of that types. If we do mat no, but I want clone often expensive is not expected to have side effects. Yes. So we are returning the whole object here. Why is this a reference? If we say that this is our result field, what's gonna happen here? Again the size. And what about this mismatch type? RS MQP result field. Found reference. Another data type that does not have ownership is a slice. Slice let you reference a continuous sequence of elements in a collection and collection. Okay. So I obviously have slice to that. But types is a field type. Types. Now we have field type. Types. Now we have here types. Okay. If we compile this, that's gonna fly. All right, we have the types for the what about now? We have that. Maybe the reverse. Yeah. Is a reference to the data it refers, it cannot be borrowed as mutable. But why I don't have the clone? Clone is returning me a new instance. Sorry, I'm stuck a bit here with this because I'm expecting to have like the whole object and not this is similar question. To whack, shuffle whack. Whack clone, let mut. Place. I didn't expect this to be so challenging to just reverse a simple vector. But yeah. Maybe to have some exact example here. So this is equivalent to vector ref. Really? Why I didn't find this? So types. Okay, what about, let's go from the beginning. So if we have for field type in result fields dot result field dot field type dot types dot ref. Not found, yeah, because yeah, maybe iter. Whoa, all right. We have the reverse now. And then, okay, field type. Okay, now we need the let MGP type equals std null ptr null mat. Okay, and then, but yeah, the problem is we need like two elements. In the case of a list or nullable, we need to take one sample. We need to take a list and then the next element as well, which is not nice. How to do that properly? Reverse iterator in Rust. No, we don't need this anymore. So yeah. Yeah, because we need a next element as well to be placed in that object. So list, inside list, we need to do a recursion. Yeah. Nope. That's not gonna fly because we need here something better than this. So we need any. Then we have to recall any. But yeah, we'll just call from the previous. Yeah, actually we good. Sorry. So MQPType. So MQPType equals MQPType equals match field type, and then we have any bool number. But we don't need this because that's gonna be replaced. That's it. And okay, field type. So for example, list is FFI MQPType list. MQPType list. Let me check MQPType list and then MQPType. Yep, MQPType list from MQPType. So that will take the former MQPType that was calculated there. Yeah, and then we also have field type nullable. FI MQPType nullable from MQPType. Nice. Okay. And yeah, that's it. So we have MQPType updated, and we're gonna just calculate here. I think that's it. So mismatch type y. FFI const MQPType. No. Mutable. MQPType. That's, I think, right. Why not? MQPType. Const MQPType. I have const MQP. Oh no. It returned const MQP. What if I put const here? Whew, crazy. Okay, I have here mutable MQPType, which is const MQPType, but this seems to work. Okay, let's try to compile this. This should actually work. Let's try to test. Boom, it works. Amazing. So, okay, sorry, I've spent a lot of time here, but I actually managed to solve the problem. So now we can have arbitrary types here. So let's just test this a bit. So if I go here, list, we have list, property is like list. What's gonna happen if I change here, let's say, now we're gonna break stuff, list, that's gonna crash everything, I think. Just a second, because I'm gonna get this is going to be ugly. Unable to prepare result within Rust procedure. amazing. It actually didn't burn on fire. Okay, great. Unable to prepare. What is that? Where is that error coming from? Unable to prepare result within Rust procedure. Okay, but this is actually okay because we have a right error. If we change here, let's say list any, and we have nullable of any, this should work. This should work, totally work. Yeah. List, we have the list, but it's not actually a list, it's nullable of any. It works. Amazing. Okay, great. Great. I'll polish these errors later on. Now I'll go back to macro stuff, try to define macro for this. So, macro by example. We want to generate a struct out of these. So how to call that first? So we'll need the name and then the types involved. And yeah. Type. Okay, let me just borrow here. Define type. Let's call it like that for now. And then we have this. And here we get what we have. So, nope. We have item block statement. Pattern expression type. Identifier or keyword. Type path token tree attribute lifetime token visibility literal. What is a literal? Sorry, I'm stupid, I know that. Identity. What do we actually want here? And we want identifier. What is this? I hope this is, I think this is expression. Expression. Okay, we have like name. Oh, sorry, dollar name. which is expression, and then we have types. So this, what is the syntax for? So this, but expr types. Okay. We need at least one of these. And okay. Okay, and then we want to replace this with all this. Result field, and then just here we're gonna print name, result field type, and here how to unpack this. Repetition. So okay. What's gonna happen here? Expression. Okay, so this comma, yeah, exactly. We repeat exactly like this. So the same is repeated. So yeah, so here like this, and then this, and then types, comma, yeah. Okay. And then we just put here, let's say, define type. So we have cstr list, and then field type nullable, field type any. Define type. All right, let's try to compile this. Boom, it works. Nice. Okay. And now we're gonna just replace all the, sorry, jang. Boom. So labels count is integer int. Nice. So we have has L3 label is bool. Okay. First label string int bool string, and then we have a bunch of strings. First label name property string first edge type and list, which is already there. Boom, we are deleting a bunch of code now. I'm happy because of that. No. Sorry. This is my editor problem. I'm gonna fix this, but we are missing here commas or something. I think this should fly. So if we compile this, yep, it works. Amazing. Okay. Okay, great. Now we have all that. So we happy with that. Maybe we can simplify that thing here, because we don't need another result type. We need just result field types. Yeah, we need types because type is a keyword in Rust, so that's not gonna fly. But we don't need result field struct at all. Result field types field type result field type. Yeah, result field type and here we don't need this anymore. All right, and here result field type array of that, yes, and then we don't need this at all. So types iter ref. Okay, great. We simplified that as well. Let's compile and test. It works. Amazing. All right, I'm happy with that, more or less. It's a bit it might be a bit confusing for a user, but yeah, I won't go into these language details. So the biggest problem is here because that user has to be aware that nullable is constructed. Nullable contains any, or nullable contains, and yeah, here let's say list of int should be correct. So if I recompile this, yeah. Okay, let's just test what's gonna happen if I replace gonna happen if I replace for example type, because so type is TT, type, no, token 3, type is TY. If I replace here expression with TY, will that compile? Found, wow. Expected expression found. What? Sorry. Expected expression while, yeah, okay. Oops. Sorry. What did happen? Oh. Sorry, I somehow I lost my PC. Just a second. I logged out or something accidentally. Sorry. Let's go back here. Here we can also enforce that the name is literal. If we put here a literal, and then okay, and we put here CSTR, and then here we don't need this. Anymore. I think this is going to fly as well. So let's try to compile. Expected struct. Nope. Define type. Labels count. Nope. Literal expression. String type, character type. Nope. Found string. about now? Ha. Why? Mismatch type. Okay, good. Nice. Nice. So we don't have to write CSTR as well here. Okay. Add read procedure. And we can also completely remove this. So if I just move this here and then okay, and then we just call vec. We have a vector here. Reference. Nice. Maybe that vector is also not something we want. Yeah. But yeah, I will leave it for now. Just not too complex stuff. We can for sure replace this vector with something else. But yeah. I'll leave it for now. Okay, let's just, what else we have here? We're more or less good here, but we have to like add read procedure that returns MGP result. Okay. MGP result we have here. So match here. Yeah. So init module procedure the following structure will not argument 2 will not live longer than the function's execution. Int. What if I return 1? Just a second. So yeah, here we have that. If there is okay, we ignore that and we return 0. Else if error, we ignore that as well and we return 1 for now. This should be okay. But yeah, that's gonna be init module. So I will but I have to no. I have to the whole So the whole lambda function will return, so memory, we're gonna replace that, but here MGP result with this, that's gonna return MGP result, and we're gonna just ignore all that here by putting this here. Like the result's gonna be propagated. The problem is that we don't have that here, but we're gonna add now. Define procedure init module, yes. So here we're gonna match this thing here, pass it memory inside, and then on OK we're gonna just return 0, error, ignore that, return 1 for now. Yep, that's it. So expected result found. Yeah, if we return an error here, whatever error we want at this point, there is no procedure. Yeah, error unable to run MQP module. Yes, great. Okay, we're gonna polish that as well, but for now we good. This is a good example. So okay, catch unwind, I'm gonna do that later on. So this is it. So we have we register module, we define procedure, we close module. Actually, yeah, I'm gonna put that at the end. No, it makes sense to have that in the beginning because like we'll list these types. Add read procedure, add read procedure. Yeah, this could be polished a lot. Add read procedure. Yeah, now I would like to turn everything into a macro, but yeah, not gonna fly. Here I need a function because I have to deal with all this, and also here what's gonna happen if I turn this off. Nothing here, but yeah, this is unsafe. Init module, have I put that in the Okay. Nice. I think I'm gonna stop here for now. Yeah. All right. So I hope this makes sense to you. And for the next time, I think I'm gonna wrap up this project next time and just like publish everything on crate.io, publish the module, and I mean document it and add additional tests and all these things. And then once that's done, I'm gonna just go through an example of a real module and explain one more time how to create a module and how to load it inside Memgraph, and that's gonna be it for next time. I really hope I will manage to polish everything by next time, and then we'll just finish the Rust query module series finally. Yeah, thank you for watching. As always, yeah, please like, share, and subscribe to stay in touch. And yeah, that's about it for today. Thank you for watching, and yeah, see you next time. Bye bye.